Welcome, everyone. I am so happy that you could join us tonight. I'm Joan Landis, and I work on providing educational programming for Weeden Island Preserve. And we have quite a fun program tonight. I'm excited to have you guys get to meet Lindsay Parsons. But in the meantime, we have a great lineup of programs coming up, all different topics across a lot of different areas. You can find out about our programming at WedenIslandPreserve.org. The programs are listed on the front page of our website. You just scroll down on the website, it's right on the front page. Or you can go to Weeden Island Facebook page, and part of the fund registration process for this involved the opportunity for you to be able to sign up for our newsletter, which is a wonderful way to keep up with preserve news, things that are going on, and as well as our programming. So hopefully you will be getting our newsletter as well. I want to encourage everybody who hasn't been out to Weeden Island Preserve to come join us at Weeden Island. Everything is open outside. We have some beautiful hiking trails. We've got a 40-foot observation tower. We've got this gorgeous fishing pier, which you can see behind me. If you're into fishing, it's a world-class fishing site. And every day at Weeden is different. So come out and find an adventure. For tonight's program, what I want to do is take any questions that you have. Go ahead and feel free to put them in the chat, and I'm going to collect them during the program, and Lindsay will answer those. I'll serve those up to her after the program, and we'll have a little Q&A. So feel free at any time to go ahead and type those questions into the chat. And then after the question and answer period, what we're going to do is have a little bit of a informal interview. I've got some questions for Lindsay, and I hope that you'll be able to get to know her a little bit better, what it's like to make decisions that she has and focusing her research, and a little bit more detail surrounding that. So now I'd like to introduce Lindsay. Lindsay Parsons is a second year master's student in geology at the University of Georgia. And she is the 2020 recipient of the Aware Levitt Foundation Student Research Grant, which is a wonderful honor. And she is doing some fascinating research on bay scallops, and is able to find out, and her research is revealing a lot about how those communities lived and what the environment was like in the Tampa Bay area in those ancient times. So Lindsay, thank you so much for coming and being with us tonight, and I am going to turn it over to you.
Awesome. Thank you so much for letting me come out today and talk with you guys about some of the work I've been doing recently. So I'm really excited. So I basically use geology and archaeology principles to understand how scallops in archaeological deposits may reflect some harvesting practice changes as a cultural response to climatic change. This is from AD 850 to 1600. So I'm working in two different cultural groups. So I'm working with the Tocobaga, which are more central Gulf Coast Florida, think Tampa Bay area. This area has been occupied since the Paleo-Indian period that started around 20,000 BC, although I'm focusing mainly on the later Weeden Island Safety Harbor period, which is from 890 to 1750 AD. The second cultural group I'm working with is the Calusa, and these guys hung out more in southwestern Florida. They were occupied the site between 500 BC and 1750 AD. These are both similar cultures, and we'll dive into a little bit more about the culture and who they were and how they survived. And so they are marine cultures, and they subsisted off of resources near them, obviously. So they ate a lot of bony fish, scallops, oysters, hard clams, and things like that. And they would harvest these by using nets, spears, boats, and they would even like wade out into the water or dive to get their resources if they needed to. They also build these man-made canals and had live wells on their sites that we still see today in some sites. That would help with the preservation or the resource proximity, as well as just having the resources available to them. In addition to these like canals and live well structures that we see in their sites, we'll also see these huge mound deposits as well as midden deposits. These mound deposits, as you see in this image right here, they were for infrastructure, ceremonial purposes, burials, and they just really can tell a lot about the cultural building of this, these cultures, and then as well as middens. And middens are basically deposits of remains from food. So you see a lot of shells and bones and charcoal in these midden deposits as well. Both the mounds and middens are kind of peppered with artifacts like ceramics or jewelry or tools, which can tell us a lot about the culture itself and kind of how they live their day-to-day life. But a lot of these sites, they tell us things that might not be immediately obvious, such as like site hiatuses, where they would abandon their site because resources weren't readily available, or that also tell us about the cultural hierarchy within the site. They have different architecture within the site that tells us about chiefdoms and where they lived and how they lived, and then just general food resources as well. We can tell where and when or how they prepared their food as well as what they ate. So they would deposit these remains kind of chronologically. So you'd have the oldest deposits building up to the youngest deposits at the top of the mound and midden site ridges. So I'm working in two different sites. The first of which is the Bayshore Home site. It's near Tampa Bay. This site is associated with the Tocobaga culture. My test unit 2 that I'm working out of is on the landward side of the Shell-Midden Ridge. And then the second site that I'm working in is Pineland or Pine Island Sound area. And I have two different proveniences from this site. So I have a mound provenience as well as a midden site that I'm working out of. And that one is associated with the Calusa culture. So I am using the scallops to understand how harvesting practices might have changed as a response to climate change. And so I wanted to talk a little bit about these known climatic intervals that we see in the Holocene. And we kind of see the cyclicity between this warmer period and a cooler period, going into a warmer and a cooler period. So you have the Roman warm period, followed by the Vandal minimum, which is cooler. The medieval warm period speaks for itself, it's warm. And then the Little Ice Age is the following cooler period. We see in literature and past research, as a paper in 1991 showed, that even sea level was rising and falling during this time. This was based off the study of shelf beach ridges. So this Wolfret is associated with this Roman warm period. Then you have let me move my people. You have a low in the Buck Keef and the Vandal minimum. You have a La Costa, which is the medieval warm period phase, and then the Sanibel 2, which is the Little Ice Age phase. And so we do see a rise and fall in sea level change, as well as there were some studies done off of Pineland. Wang et al. 2011 and 2013 did studies on otoliths as well as hard clam shells to look at the environmental conditions during this time. And what they found was that during the Roman warm period, transitioning into the Vandal minimum, you had a warmer, wetter climate during the Roman warm period and a cooler, dry period during the Vandal minimum. And it's hypothesized that the medieval warm period and Little Ice Age have a similar pattern, where the medieval warm period is a warmer, wetter period, and the Little Ice Age is a cooler, drier period. Now, these periods are not these drastic, huge ice caps in the cooler period and, super hot, you can't live in it when the warm period. There are minor changes, but they do affect the ecology and ecosystem in southwestern Florida, which then affects, the resources that these native communities are actually eating and using. So as mentioned before, it's really important to me to understand the ecology and biology of the food resources themselves in order to understand where these native communities might have been harvesting, or what tools they might have needed to bring this resource in. And so my study is specifically focusing on the bay scallop, or the scientific name is the Argopecten iridiens. And these guys, they live for a few years, but they grow really, really fast if they live in favorable conditions. They really like estuarine waters, shallow waters, 1 to 2 meters depth, and live in seagrass beds, which kind of protect them from predators and give them some kind of security. They filter feed organic matter, as that's how they eat, with these little finger things, and they also breathe oxygen through their gills. And so they, from this environmental nutrients that they have, they can actually grow their own calcium carbonate shell, which we can then later study to kind of give us an idea of these environmental, the environment at that time. They really prefer warm saline waters, so Florida's perfect for that. However, if the water gets too warm, like really hot, or you have a lot of freshwater input and the water becomes less saline, they can run into some trouble. So if these unfavorable, really hot, less saline waters persist, the scallops will actually conserve their energy and cease growth. So they'll not grow as big during these times, not grow as fast. And we can see that actually in the shell, and I'll show you some images of that a little bit later. But these unfavorable conditions in Florida typically most likely happen around the high summer months, where you have a lot of rainfall and it gets like really, really hot. Just like us people, we don't want to exert too much energy when it gets that hot. So for my project, I'm basically reading the shell. I'm looking at the shell and trying to understand anything that will give me clues to what the environment was like and why, how these native communities were actually harvesting these shells. So I'm looking at the shell itself as well as depositional patterns in these deposits. So I'm looking at body size, how big the scallop's actually growing into adulthood, biologic influence. So like what other critters are on the scallop, they'll leave trace markings. And that's really cool. And we'll go into that in a minute, as well as preservation. So preservation is really important to talk about when you're thinking about things that have been preserved for hundreds and hundreds and hundreds of years, that if they get weathered, you might not see the same, clues as you would if something is preserved really well. So that's important to understand, that just the environment that they're deposited in can actually affect how the shell looks once we excavate them. And then finally, I'll be looking at chemical analysis. So these shells are made of calcium carbonate, and I'll be looking at stable isotopic ratios from oxygen and carbon, which we can get from that calcium carbonate shell. To understand all of that data, I have to group the scallops into groups based off 2 different criteria. One would be the site. So obviously we discussed the Bayshore Holme site, which is associated with the Tocobaga, and the Pineland site, which is associated with the Calusa. And so within each site, I'm subgrouping them into climatic intervals. And we know these climatic intervals because of the time period that, they happened in. And we can tell that because of stable isotopes done in the past and beach ridges that I just mentioned. So the medieval warm period happened between 850 and to 1250. And then the Little Ice Age was after that, from 1250 to 1850. So the medieval warm period scallops will be lower down in deposition, and the Little Ice Age will be above it. And we know these dates, these strata dates, because we radiocarbon date charcoal, bone, and shell that come out of the same level and strata and so we can kind of correlate those dates and say, the shell was actually deposited at the same time that this piece of bone was, or this charcoal was. So that's how we are able to group the scallops into these different criteria to then tell a little bit more about the environment at that time. So to give you an idea of how I collect my data and what it means, I look at, the body size, as I mentioned. So scallops, they grow outwards just like a tree would. So the bottom right here, it's called an umbo, and the scallop will actually deposit these daily growth ridges and grow out. So this would be like the final season of growth in this last edge right here. And so I measure from the umbo to the final season of growth on the longest axis of growth, and that'll give me the body size so I can know, how big it got into adulthood. Also, with these daily growth rings, they help me estimate the age. So as I mentioned, during those high summer months and unfavorable conditions, the scallop will actually slow down growth, creating these really condensed sections of growth rings. And so if you look at the profile of the scallop, sometimes we'll even create a little hump. And with that, we can feel how old the scallop is, or we can even sometimes see it if they're preserved really well. And we're able to say, okay, that represents a year of growth. So to give you an idea, for this scallop in this image, this would be the growth ring right here. We have a bunch of condensed sections. And so from the umbo to here would be a year of growth. And then if this was a second growth ring, that would be the second year of growth. So I would call this scallop 2+ years of age. So that would be an adult scallop. Now, so I'm reading the shell as well. And so I'm looking at that biologic influence, the biota present on the shell. And so they're grouped into a couple different categories. So they have predatory boreholes, you have biorotors, as well as bioencrusters. So bioenrotors, these Entobia is basically a name for a trace fossil of a boring sponge, and they make these little freckle boreholes all along the shell. If these happen, it's not a big deal. It's not detrimental to the scallop itself, but it definitely leaves its mark, and it's there even if the scallop is heavily weathered and all that. So, and then we also have spionins that will create these little canals within the shell. And then for the encrusters, we see things like oysters and barnacles that are left on the shell. These really only happen when the shells are preserved really well. So we wouldn't actually see these if the shells are heavily weathered and they have that fur, they've just been nicked off or whatever. And finally, we have these predatory drill holes. And what these tell us is pretty important. So these gastropod boreholes, these are made by a predatory snail. And what they do is they bore into the shell, and if they get all the way in, it can actually kill the shell and kill the scallop, the animal itself. And so if these shells are seen in deposition, we know that the shell was actually dead, an empty shell, didn't have any meat or food resource for the native communities when it was brought in. It was actually, saw its fate when it was still living in the water as an animal live, and it had its own natural predation. So what we can do with that is we can create these live dead ratios in these groups, these subgroups that I'm creating, and we can compare the groups to see which one has a higher live dead ratio or a lower, and it can tell us a little bit about the harvesting methods, and we can go into that in a little bit more detail later on. So that's what biota tells us. And then finally, I'm doing a chemical analysis of the shell. As I mentioned before, these shells are made of calcium carbonate, so we're able to use the stable isotopes of oxygen and carbon to tell us more about the environment for when they were actually alive and living beings in the ocean, or these estuarine environments. So what I do is I drill and I mill out these small little bits of powder of this calcium carbonate shell along the longest axis of growth of the scallop, starting with its juvenile age, going into the adult age of the last season of growth. And that will tell me a little bit more about the environment throughout the scallop's life, as well as comparing groups of scallops together. So you have the medieval warm period scallops versus the little ice age scallops. So going into what they'll actually tell us, so oxygen, we're using the ratio of stable isotopes. So oxygen actually can tell us temperature. It has an inverse relationship with temperature, which means that as temperature increases or is really hot, you'll have a more negative delta O18 value or oxygen value. And if it's really cold, you'll have a more positive oxygen value. So I drew a pretty simple illustration down here to kind of demonstrate this. So you have a more positive here and more negative down here. So these tall peaks right here would be the winter seasons, and these low peaks would be the summer seasons, because this is one scallop through time, starting with the youngest season of growth, going into the final season of growth. So that can tell us a couple of things. It can tell us seasonality, how different the summer months were from the winter months, as well as it can tell us the age of the scallop. How many seasons did it live through? So if you have winter going into summer, going back into winter, that's a year of growth. So that can tell us the age. It can check the age that we estimated already, which is really important because sometimes you can have growth succession lines that are created from, predation, shell repair, and other things. So it's really important that we check that these estimations are actually correct. And then finally, with the oxygen, we can compare, like I mentioned before, the warm period to the cool period. So you'll actually see in the warm period that this sinusoidal curve will actually become more negative altogether, and it'll just move down as an entire curve. And then in the little ice age, where it's cooler, we hypothesize that this curve is actually going to become more positive, representing that cooler time period. And then for carbon, relatively, it's talking about marine productivity. So scallops, when they're young, they have a really high metabolic activity, just like you would think with a toddler or a young child. They're always, eating and they're just growing all the time. They're growing really fast. But then as, we get older and we reach adulthood, we start to slow down and enjoy the finer things in life. So you'll see this high metabolic activity. And then as the scallop ages, starting at the young, going into the final season of growth, it'll start to level out. So for a time when the scallop is having a really favorable marine conditions and it's not too hot and there's not too much freshwater input, you might see that this metabolic activity of the juvenile stage is actually more positive, meaning that it's a higher marine productivity during that time. Or in a less favorable conditions, you're going to have a more lower, and you're just going to move that curve down or make it more flattened. So to kind of categorize this data and understand it a little more, I had to kind of group it into subgroups, talking about adult body size. So these are the scallops that are 2+ years old, fully grown, and how big they're growing. So we can actually look at how big these scallops are growing into adulthood and not just, comparing juveniles to adults. So we're taking out the adult bodies and comparing the averages of the two body sizes, adult body sizes. I'm also looking at age ranges within groups. So if I'm looking at medieval warm period versus little ice age, I'm looking to see if they're ranged from small juveniles to mature adults, or if they're all kind of clustered in one age range, to actually look at depositional patterns in, these test units and how they're excavated. And so it tells me a little bit about the harvesting methods, of how these native communities are actually, what they were bringing in and depositing. And then finally, I'm looking at that live dead ratio, and I'm looking to see if, we have a high or a low comparing between the two climatic zones. So I've been working in Pineland for a while, and I have some preliminary data that I've been looking at. We're still waiting to get some more dates back from Bayshore Homes, but once we get those, we're able to do the same similar thing and look at those patterns. But for Pineland, which is associated with the Calusa, we saw during the medieval warm period that the adult body scallops, the size of the adult scallops, was smaller than it was in the little ice age, meaning that these scallops in the hotter, wetter medieval warm period just weren't growing as big as the scallops were in the little ice age, where it was a little bit not as hot and more saline water. So it was like their happy place. And then I looked at age ranges again, and we see a similar trend where you have these small juveniles all the way into adulthood, and you see them sporadically spread out. But then in the little ice age, we kind of see them all grouped in the adult range, around the same size. You only see like maybe one outlier. And then finally, we looked at the live dead ratios, and we saw that during the medieval warm period, a third of the shells that were brought in were not used as food resources. The shells were just empty shells and were dead upon collection. Whereas in the little ice age, we saw a very significant drop in, the amount of shells that were actually dead upon collection. So I'll go into a little bit about what I'm hypothesizing this to mean. So because in the medieval warm period, the scallops weren't growing as big, they're smaller adult body size, more unfavorable conditions. Maybe there wasn't as many of them. They were more sporadic, harder to find. That the native communities were actually using a bulk collection method. And this is supported by the idea that you have a higher range in body sizes. So you're bringing in juveniles, adults, doesn't matter. You're bringing it in, trying to get any kind of food resource you can out of these scallops. And then also you see in the medieval warm period, which is this column right here, that you have more dead shells upon collection, more empty shells. So during this time when maybe the scallops weren't as good, advantageous of a resource, the native communities had to do more bulk collection, where they're going for quantity over quality. And then you shift into a little ice age, which is a cooler, less wet period. So you have those perfect warm saline waters that the scallops love. And so they're becoming bigger, they're more productive, maybe they're spawning more, they're more, they can find them better. There's just more of them, and they're actually in this, and I'm suggesting that they are hand selecting during the little ice age. And this is supported by the fact that we're only seeing like these really pretty uniform size and deposition, and much less dead shells and collection. So any shells that they exert energy to bring in to harvest as a food resource are actually being used as a food resource. So the takeaway message is that, transferring from a warmer, wetter period into a cooler, drier period, that we see, a shift from a bulk collection method into a hand selecting method. And this is based off of the environmental conditions we know about the scallops, as well as the depositional patterns that we see in these deposits. So this is important because scallops can tell you about the environmental context, not just with one scallop. We see seasonality in just one scallop with those isotopes, as well as marine productivity. We can look at depositional patterns, but it also tells us about cultural responses to climatic change. So we see the shift in that environmental change from the medieval warm period into the Little Ice Age, and it can kind of represent a change of harvesting methods. And then it's really important to understand that for the southeastern United States, that these Holocene climatic changes, they're not drastic. They're, they definitely are seen, but they're not like these huge ice caps, like I mentioned. So even these small changes are affecting the, estuarine environments and the ecology of the whole system, including the cultural anthropogenic, people who are using these environments to subsist off of. So it's important to understand that even small climatic change can show you a huge shift in, cultural response. And then finally, just the use of scallops as a food resource. So in deposition, we see more commonly like oysters and hard clams and gastropods, but scallops are also seen. And these guys, because they have a spawning season only once a year, which happens in fall, it's really important to understand the season of capture. So that final season of growth, we can tell when they were actually brought in and captured, what, if it was a colder month or a warmer month, or if it's just kind of all over the place and it's only one season, then it might be ceremonial, or, they're practicing, sustainable harvesting practices where they know they have to wait till after the scallops spawn to harvest them. So it's really cool. It would be really cool to see, if there's a pattern in that as well, which we'll be able to tell from the stable isotopes. So I also want to take a minute and just tip my hat to the scientific community, that it's not just, one person, it's a whole team of people and expertise, and the people that come before you and the research that's done prior. It really helps, build this kind of interdisciplinary project. And not only that, the funding. So I'd like to take a moment to thank Aware Levitt Foundation for allowing me funding my research, because it's so essential. The stable isotopes can be quite costly. And like I mentioned, that without the stable isotopes, I wouldn't be able to for sure say like, yes, this is a warmer, this is a cooler, or these are the ages of the scallop. It helps solidify some of those estimations that I'm making in my preliminary work. So that really goes a long way. And I just want to say thank you to Aware for allowing me to work with you guys on this. And then also I want to take a moment to thank my committee members, just because my research is interdisciplinary, but my committee is interdisciplinary. And I think that's what makes it work. I have, people from paleontology, from archaeology, from, geology, who work on stable isotopes with stalactites and stalagmites. And so I have quite the range of people who are helping me and kind of coming in from their corners of expertise, kind of bringing it all together. And then last but certainly not least, I need to thank the people who are actually loaning me my scallops. I was not actually able to go out in the field and excavate them myself. So I'm getting them loaned to me from Dr. Austin and Dr. Karen Walker. And these guys actually excavated the scallops, put the hard work, blood, sweat, and tears into it. And they've been such a help, allowing me to ask them questions after questions about the age, about the context, about the excavation process. And it really is helpful. And I think it's worth mentioning that it takes a village to do any kind of scientific work. And I have quite the team behind me, and I'm so, so thankful for that. So that is my research in a nutshell. And I'm happy to take any questions or pass it back over to Joan and talk with you guys a little bit more.
That was fascinating. Thank you, Lindsay. Well, that was a fantastic presentation. I mean, it's amazing what the scallops can tell us, and about the past. And I'm really fascinated about all of the influences, not only in people, but in the scientific specialties too. We you were able to explain very sophisticated science, very sophisticated processes that you're using in your research, and well enough that we don't have questions from the audience. So now what we get to do is get to know you just a little bit better and how the thinking was and your process of coming up with your master's thesis project to begin with. It's perfect that you have that slide up now, because I think it's really fascinating how you referenced the interdisciplinary nature of your work, and um, talked about the people and the agencies that have helped you do what you do. Um, can you help us understand how you manage so many different scientific disciplines, and are able to, uh, distill them into a succinct research model, and come up with the data that you are? It's a really really interesting process. I'd like to know. We'd like to know more about.
Yeah, no, I when I started, I was a geology major, and I was working with Dr. Walker because I took her paleontology class, and she is just a phenomenal paleontologist. She works with scallops and oysters, and she knows about, the preservation of fossils, and she's just fantastic. So I was very interested in that. And so we came up with this project about trying to figure out difference of scallops and the environmental, context, and how, climate change might have affected them. And so we reached out to Victor Thompson, and he was able to talk with us about, there's this great pineland site we're working on, and I have these scallops for you, and you can look at them all you want. So we were looking at the preservation and how everything, kind of added in together. And then so we kind of created this project together, and with Bruce on board, we were able to talk about stable isotopic analysis, and kind of join that all in. And so I'm constantly emailing them all, talking to them, and being like, I don't understand this is new to me, like, help me. And so because they're all from different corners of science and the scientific community, and they all have so much experience and know-how, that I'm able to do what I do and understand and kind of talk about it in a way where, like, it's joining all of them. Because without the interdisciplinary cooperation of my team and my committee and all that, I wouldn't be able to do what I'm doing. But yeah, it's just been phenomenal to be able to have those people who have those very specific know-how, and being able to help me and hold my hand and walk me through, the new archaeology stuff, because that was all new to me. That was a learning curve, all in itself. So, and it's really, yeah, everything's kind of interconnected in the real world. So I think it's awesome to have that in the scientific world as well.
That is fabulous. Yeah, that's so true. Everything is connected, and it sounds like you've had such a positive experience with experts in the field and professors, and everything helping you connect all the different parts of your research. That's fantastic. Um, not probably to undervalue your particular abilities, and interests, and talents as well, obviously. So uh there are so many different aspects about your research, and um so you're this isn't the only thing that you do at school, right? I mean, you have classes, you have meetings, you have other things. I wonder if you could walk us through a day in the life of Lindsay Parsons, master's student.
No, I that's a great question, because I just think, being a master student really allows you to kind of, yeah, build yourself, and like learn all the things that you're interested in. So like for me, like you mentioned, I definitely take classes, and I'm able to learn about different things in geology and archaeology. And kind of being a master student allows you to take classes outside of your or your major, realm. So that's been really fun to learn. I've been taking lots of different interdisciplinary classes so I can, help myself learn for my thesis. But not only that, just for my wealth of knowledge. So definitely classes, that's always difficult, not difficult, but you know, a fun add-on. But the big thing with masters, my thesis. So I work in Victor Thompson's archaeology lab, and in that lab is the same lab I do my drilling in as, and I work in Sally's lab, Dr. Walker's lab. And basically what we do is we take all of the shells and we look at them. We look at their preservation and their weathering and the biotic influence and, all of that. And we measure them and we get all that data put together. And then we go in and we pick out select shells that we want to do the stable isotopic analyses on. And that's when I go to Victor's lab. And thank goodness that he has let me be one of his students in his lab working on one of his projects, because I have gotten so much experience drilling and milling and weighing sample powder that I feel very confident about it. But like in Victor's lab every day, we drill oyster shells and hard clam shells, and we mill out that powder and we weigh it and we submit it for stable isotopic analysis here in town. And so I'm able to then have that know-how to then apply to my own research. And so it's just been a wonderful process of being able to learn these in the lab, as well as, incorporating my classes. We have field trips and field school, and, it's just, I really get the full, I get a little taste of everything. And I think that's just I'm so, lucky to have that kind of experience with school, to be able to also, do my research, but also learn new things.
Yeah, I mean, you're busy, busy. It was fun. You and I have been talking about getting this together for a while, and I've been, kind of working around your very busy schedule. And again, I mean, I can't thank you enough for spending time with us tonight, and taking a little break, and also for breaking this down for us in a way that I think is very accessible, and that's not always easy to do. You have your head in a huge project and are working with specialists and elite scientists, and I want to thank you for breaking this down and making it so consumable for us. And I mean, looking at the analysis that you do, knowing who has attacked that scallop and what sort of a life it has, and so on. It's I want to thank you, because that makes your work and your associates work so easy to understand and relate to. So, and it's not easy,
No,
so I appreciate you doing that for us tonight. So this is why scallops. How did you end up on deciding that scallops were going to be your focus?
Yeah, so I mean, Dr. Sally Walker, we had a meeting. I was like, I want to do research as an undergrad and I want to get into this, and I think it's so cool. And she worked on shells, like I said, and I was taking her paleontology class. And I just got really into like how everything's interconnected. And she was like, well, let's do something with climate, and scallops are a great, tell for that, because they react with their environmental conditions so well. And so we started looking at like what we could do and throwing out projects. It was kind of like cooking spaghetti. We'll see what sticks, So it was so much fun. And, we were throwing down different ideas, reading a bunch of papers. And then we finally came across, like, okay, what about if we looked back in time, and not just because, we're looking at modern scallops and how it changes with climate now, but we're like, what if we go back in time? And it was great because archaeology, geology is wonderful, but when you're dealing with millions of years, some things just don't preserve and you might just not have anything. So archaeology is wonderful in the way that like everything is just like, it's there, it's recent, it's accessible, like it's tangible, time periods. So it's not so far away where it's, incomprehensible. And so we reached out to Victor, Dr. Thompson, and he was just wonderful and so helpful, and was like, these are what I have, you're welcome to look at them and see what you get. And it was more like a spaghetti thing again. We were just like taking all this data and just like throwing out, ideas. And he was like, this is great, because he knows archaeology and he knows the cultures and like kind of what it means. And he was like, this is fantastic. Like, this is great. This is what it means. And like, you should definitely go forward with this. So then we started to kind of like fine tune and like figure out what was important and what wasn't important. And so that's kind of how we developed the master's thesis that I'm working on now. And it was kind of this really beautiful progression of like, what's fun to me, what's accessible, what, has not been done necessarily before, what's new, and what questions we can ask that kind of are anchored in different scientific domains. And I think that, I loved the process of finding my project because it's kind of special to me and it's special to my advisors, and it was a lot of fun.
Absolutely. Well, and the energy that you bring to it, it's so much fun. As a matter of fact, we're getting a couple of questions popping up. And one of them is, let's see, um, it's always wonderful to see someone so into what they're doing. Speaking for myself and only for myself, this was more scientific than I expected. Let's see, let's see. But thank you, Lindsay, and best of luck in your work. Let me read. There's another question up here real quick. Oh, Lindsay, is there a particular area at Pineland where the scallops were collected? Randall Research Center and the shell middens near the Tarpon Lodge is a question. The Calusa were collectors and aquaculture specialists, very active in Southwest Florida. The Tocobaga were further north and dependent on the Gulf and the uplands for their subsistence. Can you draw any conclusions or differences in the two cultures from your research?
I'm going to have to maybe read that. Is that in the chat? Just to
Yes.
be up on it all. There it is. Yeah, so Pineland scallops were collected very coastal, Pine Island Sound. And I can go back to that slide real quick. Just put the chat down. Uh-oh. Oh. Well, it's not going to let me now. But Pineland scallops, so they're collected in a mound site, and there's a midden site that's like related to the mound, is like kind of fall off of the mound. So you have the mound site that's, all the medieval warm period. And then farther down, it's like where it slid down at a lower level. And those are those midden deposits. So they're all connected, but they have a mound deposit and then a midden deposit. And those are coastal Pine Island Sound. And let me pull up that chat one more time, finish the question off. And it was Pine Island Site Complex is where these are coming from. So near the Randall Complex and Brown Mound. Sorry, I'm trying to get this all on the same question.
No, that's fine. Take your time, Lindsay. It's distracting to read and then formulate at the same time. Take your time.
My is going way faster than I could read. Very active in southwestern Florida, Tocobaga farther north and dependent on the Gulf for uplands. So from my scallops that I see, I don't necessarily see any huge differences so far in the how the scallops are deposited or what else was there, but we do see in Pineland like a lot of coastal like dolphins they have in deposition there, which is crazy to me. And so the Tocobaga farther north in Bayshore Holmes, that's also a more like seaward site than in the Pine Island Sound. So we could see, other depositional things within, but scallops themselves are pretty much the same in both the Tocobaga and the Calusa deposition because they are the bay scallops and they live in similar, environments. And so the harvesting methods would have reflected the same thing. And what we are seeing though is that in the Tocobaga Bayshore Home site, we're seeing this huge shift in the levels. So like different weathering within the levels. So that could mean that you have some crazy storm events that are kind of like stopping or like kind of separating out the different levels where you might have erosional time. So it's not as smooth of a gradient as you would see in Pineland, but we're going to get some more dates from Bayshore Holmes that are going to tell us a little bit more about the actual time periods they came from and when they were deposited and how quickly they were deposited as well. And I think that'll be a really good insight into kind of talking about the depositional patterns that we're going to see from that site specifically.
Fantastic. That was a big question. Okay. So I was wondering, and I'm sure others might be curious, if you have had any surprises, if you've come across anything that you didn't expect, or if you have had an aha moment.
Yeah, my big aha moment was when we were kind of having a meeting, and it was me and Sally and Victor, and it was me just kind of telling them like what I found. These are the scallop body sizes, and like there wasn't any really conclusive, separation into groups. And Victor was like, wait a minute, like look at the differences in the body sizes and the differences in, this. And Sally was like, oh my gosh, look at the biota, you see a lot more dead shells. And he was like, this is huge. They're actually harvesting. It's not just like storm wash up or whatever. So that was kind of the day when everything shifted from like, okay, this is an undergrad to like, this is something that really could be important and something I can write about and publish and talk about and really get into. So that was like a huge moment. And that was like the day I came home and I was like, all right, I'm gonna be a scientist. Like, I'm so excited. I called my mom and it was just a wonderful day because it was like, okay. And then the best part was that we kept finding similar things. And like the more I would read and talk to different people, they would say, like, this is like, this makes sense. Like, this is correct. Because I mean, even in deposition, we have more scallops, like numerically in deposition in the medieval warm period, which would say, okay, they're bringing in more bulk. So like whether or not they're actually, using them as a food resource, there are actually more shells there because they're just, bulk. So it's like, and it always is like things like that. So it's just been a wonderful kind of like, yes, okay, like let's keep this train going. Like let's keep it making sense, Yeah, no, I've loved it. I think it's great. And every time you have those moments, small or big, it's just like, all right,
Yeah,
good.
definitely. Definitely. Okay, well, so let's see. What um, would you like people to take away from the work that you're doing?
I think the big thing is just, scallops are not as prominent in these midden mound sites. They're far and few in between, less than, you see like oysters or hard clams or gastropods. And I think it's really important to understand like even small, quantities doesn't necessarily mean that it's not going to tell you anything because, it's been wonderful to see, how much these scallops actually reflect this change and environmental conditions. And I'm so looking forward to getting back my stable isotopic, results to like really like nail it down and solidify my hypotheses or whatever. So I think that it's just wonderful to say like, any little thing in the deposition. And like, it's so exciting to me to think like there's so many other little baby things that maybe have been overlooked in the past that can really, somebody can look into it and find this whole new world of what happened or harvesting practices or cultural, whatever they want to find out by using these small niche things. And I think that's really exciting, and doing interdisciplinary work and things and having like the community that I have.
That's fantastic. I think, listening to you and the energy that you have and everything, I think is, I'm really happy that we're able to dig in a little bit more where you can explain those factors because, it's going to be very helpful for students out there trying to take that next step and to try to understand the challenges and understand the community that's waiting to help support them in their efforts. And also the enthusiasm of you taking that next step and the next step and the next step and seeing where your research is going. Really, really, really cool. Really, really neat. Appreciate you, breaking it down into those pieces and letting us kind of walk
Oh,
through that
I think
process.
I've told you before, I've loved being able to like break it down and stuff because sometimes you just get so bogged in and zoned in and you're like, this is the next step, this is the next step, but you don't ever like, look back and say, okay, this is the whole picture. And it's been such a like an awesome thing for me to go back through and kind of like come up with different ways to say it, and I loved it. It was awesome.
So speaking of next steps, have you thought about what you want to do after you finish your thesis?
Yeah, I mean, a little bit. So I'm expected to graduate in May of next year. So next this
Yay!
upcoming summer. So I'm excited about that, to just have that under my belt. And I would love to do, go for a PhD position eventually. But with all honesty, I love my whole reason of going into geology was to be out in the field and, get my hands dirty and, roughing it, as a
Mhm.
scientist. And I love that. And I love the fact that I had scallops loaned to me, but I really do enjoy the fieldwork aspect of geology and archaeology. And so I think I'm going to try and maybe take a couple years and just sow my wild oats and let my hair blow in the wind and just be out in the field and get dirty for a couple years and then go back into the science world and just but I'm really looking forward to having like a breather where I can just, I don't know, I'm thinking about moving out west and it's so pretty out there. So yeah,
Wow.
my next stage, and I'm so excited, but I could not have gotten as far as I have without this project and without my thesis and without, the people backing me. So, so grateful for it. And they're also understanding and welcoming because I talk to Dr. Walker and Dr. Thompson about it all the time. I'm like, these are what I want to do. And they're like, go for it. Like, get it. Like, I'm so proud of you. So it's really, really a true blessing to have those people in my corner.
That's fantastic. Well, the world is wide open, and I want to wish you all the best. Not that you need any wishes of bests for graduation, but you've been an absolute delight to have on tonight, and love being able to dig into your research and also dig in to your head a little bit more on your the path that you've taken and the people that you've surrounded yourselves with. And thank you for, being willing to share yourself also along with your research. It's really been a lot of fun to get to know you a little bit better. Um, and if when you come down to the Tampa Bay area and Weeden Island, I would love to, go out on a dig with you, or, at least meet you in person.
I love that. Yeah, I'm so bummed with COVID. We couldn't come back down, but it was wonderful. I went to the preserve and saw everything when I came down to get the shells initially, and it was awesome. I had so much fun.
Well, thank you again. Our audience really appreciates your energy as I do, and your enthusiasm, your delight. And again, thank you so much. I want to thank everybody for joining us tonight, and stay tuned for our future programs. And Lindsay, best of everything to you. Thank you so much.
Thank you guys so much for letting me tell you about my project. I really appreciate it. And thank you, Joan.
Have a
Yeah,
wonderful evening. Thank you so much.
you too. Thank you.